Keeping you safe isn't just about safety belts and airbags. An entire crash sequence only lasts about 100 milliseconds. That's about the amount of time it takes you to blink your eyes. In the early stages of a crash, the vehicle wakes up. You've got 7 technologies that all come together. When it's determined how severe the crash is, then it all goes into action. In February 2009, Ford Motor Company opened its new Paint and Body Technology Center, where we're working hand in hand with Ford Crash Safety from the beginning of the development process on a new vehicle.
Think of this building as a research center or a think tank for collision repair. We'll bring in vehicles that we are developing, and we will try to figure out what is the best way to repair this vehicle.
Typically in the industry, what would happen in service is we'd get the vehicles after they were produced and on the street, or shortly before they would get launched. And we developed repairs at that time. But a lot of times we don't have influence on the design of the vehicles, so now we work more upfront and in conjunction with product development.
Today, with the greater use of high-strength and ultra-high-strength steels, such as boron steel, in more and more vehicles, one of the keys to helping repairers return the vehicle to pre-accident condition is alerting them to the presence of these new materials. We collaborated with other automakers on the creation of a new matrix, which provides guidelines on the proper procedures for repairing several grades of steel.
Part of the secret to our success? We communicate with our Ford dealers and independent repairers. We get their input. We develop and make available the repair procedures they need in order to make an effective repair. And our genuine Ford replacement parts are the same as those on a vehicle when it was new, which contributes greatly to the effectiveness of the repair of that vehicle.
When it comes to repairs involving structural components, including anything impacting the proper operation of the supplemental restraint system, we've been out front on the importance of using genuine Ford parts and procedures. Recently, however, the entire industry has begun to take a much closer look at the issue after well-known I-CAR instructor Toby Chess used his technical presentations at the November and January Collision Industry Conference meetings to spotlight the often dramatic differences between aftermarket and OEM structural parts. An industry-wide response to emphasize safety has been a welcome sight. Today, we're going to do our own comparisons on some Ford parts and their aftermarket versions. Now we're going to compare the 2008 Focus bumper beam, the OEM offering, versus the aftermarket offering that you see here. The aftermarket offering is 2-piece, perimeter spot welded on its perimeter and its center. Note that the weld nugget size and penetration strength do not meet Ford specifications for the auto body repair manuals that we publish. You'll also notice too that this aftermarket part does not include the reinforcement ribs that you see on the Ford panel right here. Now we'll move to the Ford OEM part for the Focus bumper beam. If you notice that this is made of one piece of boron steel with a laser weld in the center for strength. Also note the reinforcement ribs on the top and the bottom of the piece. This is a 2008 Focus bumper beam aftermarket offering. We're going to do some destruction testing today. Notice I have a Milwaukee Sawzall with a regular bimetal blade. This is the 2008 Focus bumper beam OEM offering. We're going to do the same destruction test that we performed on the aftermarket bumper offering as we did before. Note that we have the same type of blade, but brand new, located in the Sawzall. We're going to have to swap the blade. Now we have the 2008 Focus bumper beam aftermarket offering, and I'm going to do a destruction test on the spot welds holding the two halves of the piece together. As we noted before, the factory OEM part is a one-piece stamped arrangement with a laser weld through the center. This aftermarket offering, you will recall, has spot welds along its perimeter. Let's go ahead and do a destruction test on it to determine how good the spot welds are. Notice on the spot weld destruction test how the spot weld simply pulled itself apart, indicating poor weld penetration and amperage strength. This is the 2004 to 2008 F-150 aftermarket radiator support. If you notice, where F-150 support OEM is actually magnesium, this is made of plastic as a replacement part. I'll call your attention to a couple of key things. Note the rivets which are used for the sheet metal reinforcements which attach the aprons to the forward radiator support. Notice that they're not fully engaged. Now I'm going to show you something interesting on the other side. If you notice in this area, these are the mounting areas where the forward insulators go. Notice the reinforcement or lack of as compared to the factory part. This is the 2004 to 2008 F-150 OEM radiator support. Note that this one is made of cast magnesium, about 35% stronger than comparable aluminum radiator supports. Also call your attention down to this point here. Unlike the aftermarket riveted example we just saw to the plastic, the OEM uses a double stack of steel bolted directly to the magnesium casting. Also note the difference in the reinforcement area surrounding the insulator mounting areas. The key thing to remember when performing repairs involving these or any structural components is they all work together to ensure the proper operation of the supplemental restraint system and the entire personal safety system. All Ford vehicles undergo a battery of crash tests before they're introduced to be sure all the parts function together properly if a customer is in a collision. Parts not manufactured using the precise specifications and materials called for by Ford engineers may not return the customer's vehicle to the pre-accident condition required to be structurally sound in the event of a subsequent collision.